Hello, Math8A students. This is a review video of the Chapter 6 practice test so that we can be ready for our Chapter 6 test on systems of equations. I'm going to show you all the answers to all the problems on here, and after I show you all the answers and you give yourself a score and a grade, feel free to fast forward, rewind, skip around, and not watch this whole video. Just watch the parts that you need to watch to help you be ready for the test. All right, that's the deal with that. Okay, so here's the answer key. And you're going to give yourself a score out of 20. Number 1, infinitely many solutions. Number 2, there is one solution. Number 3, you can see what your graph should look like and what the solution is. Number 4, you can see that these are two overlapping lines, which means there's infinitely many solutions. All right, then you can take a second and look at the answers from numbers 5 through 12. Just pause this video for a second and check those answers. And then here's the answers to the back side of this. We have word problems here, so make sure that you're answering these word problems with some words in there and some numbers as well. And then finally, number 16 and 17 are systems of inequalities. So the shaded area that you see filled in here is kind of your final answer for number 16 and for number 17. Also pay close attention to dotted lines versus solid lines on that one. Okay, let's jump in and go through problem by problem. On number 1, we have a bunch of equations over here on a graph, and we're going to look at these two equations. X plus y equals 3. That's this one right here. And y equals negative x plus 3. Y equals negative x plus 3. That's this one, right? Oh, so it's the same line. So how many solutions are there? Infinitely many solutions. All right, then for number 2, it's two different equations. 3x minus y equals negative 3. 3x, okay, so that's this line right here. And then 2x minus 3y equals negative 2. 2x minus 3y equals negative 2. So that's this line right here. Oh, they crisscross one place, and so there is one solution. All right, this already had all of the lines graphed for you. On the real test, be prepared to actually graph this yourself in order to figure out what the solution type is, okay? No problem. Speaking of which, number 3 and number 4, we're gonna do just that. We're gonna graph and then solve. So on number 3, we're gonna start at positive 3 for our first y-intercept. We're gonna have a slope of negative 1. So I'm gonna go down 1 over 1, down 1 over 1, and I'm just gonna make a bunch of dots to kind of show where this line would go. And then I'm just gonna graph the other one. The other one is going to start at negative 3. 1, 2, 3. And instead of a slope of negative 1, it's going to go up 1 over 1. And you can see pretty clearly where that thingy is going to cross. What's my one solution for this? My one solution is 1, 2, 3, 0. All right. That's the graphing method. And yes, I do want you to demonstrate to me that you know how to use the graphing method, that you remember about slopes and intercepts and all that good stuff. Speaking of which, oh boo, number 4 is not in slope-intercept form. Wah! All right, that's fine. If you need to, you can graph these by just putting numbers in and getting numbers out, number juicer style. You can do that if you need to, or we can convert this into slope-intercept form. So I'm going to do that by adding y to both sides. What? Yeah, that's what I'm going to do. So then I would get 2x equals y plus 5, and then I'm going to take away 5. And basically, I'm going to have y equals 2x minus 5. All right, you got the idea. So here's 1, 2, 3, 4, minus 5, and then slope of 2. All right, hopefully I'm not going too fast for you. You get the idea here. And then my second equation here, oh boy, I'll do minus 4x minus 4x. That's going to give me negative 2y equals negative 4x plus 10. I'm going to divide by negative 2. So that I get my y by itself. Negative 4 divided by negative 2 is positive 2. 10 divided by negative 2 is oh, wait a second. It's the same equation. Same line, infinitely many solutions. All right, we get the idea on that one. Good. Now, 5, 6, 7, 8, 9, 10, 11, 12, you can use whatever method you want. You can have some graph paper handy and graph every single one of these. You can use substitution, you can use elimination, or guess and check, knock yourself out, whatever you want to do. I'm going to demonstrate for you what I think the easiest way is on this. I think for number 5, the easiest thing is substitution. If y equals 2x, put a 2x in for y, and make it 2x plus 2x equals 8. Boom. That's 4x equals 8, right? And if you have 4x equals 8, then x would equal 2. And if x equals 2, y would equal 2 times 2, and y would equal 4. So my solution is 2, 4. Or if you want, you could say x equals 2, y equals 4. Either way is fine. All right, number 6. I think this one would be good for elimination, but unfortunately 2 doesn't match 5 and -1 doesn't match 7. So I'm going to have to do this little thingy where I multiply everything here by 7. So when I do that, I'm going to have 14x minus 7y equals 7 times 3, which is 21. And then I'm just going to rewrite this one here. 5x plus 7y equals 17. And I'm going to add, because 14 plus 5 is 19x. -7 plus +7, elimination. 21 plus 17 is 38. And thankfully, that's divisible by 19. My x answer is 2, again. And then to figure out what y equals on this one, I'm going to put a 2 right here. So if I put a 2 right there, I'd have 2 times 2 minus y equals 3. That's 4 minus something equals 3. I wonder, 4 minus what makes 3? Oh yeah, 4 minus 1 makes 3. So y equals 1. All right, good. Number 7. I think this one is perfect for elimination, and you could add, or subtract on this one if you want to. I like add. Whenever add works, I'll go with that. Those are gone. Boom, x equals 5. Whoops, x equals 5. What's my y value? Watch this. I'm going to subtract. What if I subtracted on this? I get 2x minus 2x is nothing. 3y minus -3y is 6y. And 19 minus 1 is 18. Divide by 6, and I get y equals 3. Whee, that was nifty. All right. You didn't have to do it that way, but that's one way to do it. I also think number 8 is going to be good for elimination. Okay, let's just double the bottom one so that I have a match right here. So I'm going to make that 8x minus 4y equals 8. And then I'm going to add. 6x plus 8x is 14x. 4y plus -4y, elimination. 20 plus 8 is 28. Yay, it's divisible. I get x equals 2. And if x equals 2, oh boy, how am I going to figure out the rest? Well, I'm going to have to... What's 6 times 2? 12. 12 plus 4y equals 20. Y equals 2. So your solution actually was x equals 2, y equals 2 on number 8. All right, so far so good. I think that there's going to be a lot of elimination on this one, so hopefully you like the elimination method. Look at number 9. I think this is just more elimination. 5x plus nothing equals -5, so x equals -1. If x equals -1, 2 times -1 plus 2y equals 6, right? So that's -2, so I'm going to add 2 to both sides. 2y equals 8, y equals 4. There's my solution. -1 for x and 4 for y. We're doing great so far. And I'm just going to keep on eliminating. On number 10, I'm going to do minus. 7 minus 9 is -2x. That's okay. 3y minus 3y is no y's. 1 minus, be careful your positives and negatives here, 1 minus -3 All right, divide by negative 2, divide by negative 2. That's going to be x equals negative 2. What is y? What is y? So we're going to plug that negative 2 in here or plug it in here. Doesn't matter. You should get the same answer either way. I'll do this one. 7 times negative 2 is negative 14 plus 3y equals 1. So add 14 and you get 3y equals 15. Divide by 3 and you get 5. Okay. Finally, on number 11, I would stop doing elimination and I would start doing substitution on this one. Because y equals this, so I'm going to put that where the y is, and I'm going to rewrite it as x minus 2 times that instead of x minus 2 times y. And be careful when you distribute this, because you're distributing a negative 2. If you miss this problem, I bet it's because you messed that part up right here. All right, so, yep, okay, we see the negative there. X minus 6x is negative 5x. I'll add 2 to both sides. And you get x equals negative 2. And then, yay for substitution. If you put a negative 2 right here, you get y equals 3 times negative 2 plus 1. So this one was negative 2, negative 5. Negative 2, negative 5. Finally, number 12. I think we're back to elimination on this one. This is a minus, minus, minus. 5x minus 5x, elimination. Be careful with the negatives here. Negative 15 minus negative 4 is negative 11. Negative 20 minus negative 9 is negative 11 also. And so that means y equals 1. So we know this part. What about the x part? So if I put a 1 right here in this first equation, I'd get 5x minus 15 times 1 equals negative 20. So I'm going to add 15 to both sides. Hopefully you guys are okay with me kind of maybe semi-skipping a step there, and then divide by 5. And you get negative 1, 1. Okay, hopefully that makes sense. Hopefully we're okay on the front side of this. Now let's get to the fun part. Word problems. Number 13, I don't think is too bad. Number 13 isn't too bad. The sum of two numbers is 16. So sum two numbers, we don't know what they are, but they add up to 16. And their difference, difference is subtraction. So, boom, there's your system. Yeah? You could do this by guess and check if you want. Is it 8 plus 8? No. Is it 10 plus 6? I don't know. So I would solve it by elimination again, right? It's lined up. Everything's good. Add, add, add. 2x equals 36. So one of your two numbers is 18. What's your other number? Well, they have to add up to 16, so it must be negative 2. And then just reread it. The sum of two numbers is 16. Yep. And their difference is 20. Is this minus that 20? Yep, checked. All right, the challenging word problems are going to be number 14 and number 15 about Kyle and Brent. We got to make equations out of these. Kyle started a new job, $7 an hour. He was making $5 an hour. Set that aside. We don't need that yet. Kyle worked a total of 54 hours. Okay. Between the two jobs. So, job 1 and job 2, the total number of hours added up to 54. So let's say this. Let's say the number of jobs he worked at his current job and the number of hours that he worked at his prior job, you could say old and new, I just don't like using O as a variable, added up to a total of 54 hours. All right. So the current job hours and the prior job hours were a total of 54. Now, he made $338 total. How did he make that? He made 7 times however many hours he worked at his current job. That's how much money he made at his current job, right? His current job, $7 an hour. So 7 times however many hours he works is that amount. Plus, he also made $5 at his prior job per hour. There's your second equation, and you're just going to use substitution, elimination, graphing, guess and check. Some way, somehow, you are going to solve that system of equations. The hard part on this one isn't solving it. The hard part is writing it in the first place, reading it and writing it. So be careful about reading and writing and setting up your equations. The rest I think you can handle on your own. And the answer on this one is, oh, wait a second. When you solve this one, you end up getting C equals 20 and P equals, wait, no, it was the other way around. P equals 20 and C equals 34. That's what you end up getting. So how many hours did he work at his new job, or what I called his current job? 34. So you got to read really carefully here. 34 hours is how many you worked at his other job, right? I could see you maybe getting mixed up about which one is which, so be careful about kind of how you handle the details there. Probably the hardest question on the entire practice test is number 15, because it requires you to know how much a quarter is worth and how much a dime is worth. Oh no, but you know that. He has 23 coins in all, and it's quarters and dimes. So the number of quarters plus the number of dimes equals 23. That's the easy part. He also has $3.35. How does his amount of quarters and dimes add up to $3.35? Well, take 25 cents times however many quarters he has, and then take 10 cents times however many dimes he has, and that's how it adds up to $3.35. And boom, there's your system of equations. Magic. All right, so now that you see it, I bet it makes sense. I bet the challenge here was just reading and writing and not knowing how to do that yourself. So now you see how to do it. You know how much a quarter is worth, and a dime, and a nickel, and a penny, so we could do this kind of a problem for sure. And the rest of this is going to be just solving substitution, elimination, graphing, however you want to do it. One thing I might encourage you to do on this one is maybe multiply the bottom equation by 4 so that 4 quarters equals a whole. Or you could even multiply everything by -4 so that this 1 quarter would eliminate with a -1 quarter, and you could add. Either way, it's asking find the number of quarters and dimes this time. So he has 7 quarters if you solve it correctly. And he also has 16 dimes. How do you know if you did this correctly? Figure out what 7 quarters and 16 dimes is worth, right? And then just see if it adds up to $3.35, right? So it's pretty easy to check your answer here. All right, real quick, I'm going to go over number 16 and number 17. This is in slope-intercept form, so I'm just going to start at 1. I'm going to go up 1 over 3, or down 1 backwards 3. It's a dotted line, dotted, and I would shade below. Okay, I'm going to shade below this line, but I'm not going to do the shading yet. This one I'm going to start at -3, and I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. This one's going to be a solid line, so make sure you get all the details correct. And it's also less than, so it would be below this line. So what part is below the red line and below the blue line? The solution area is this area right here. That's our solution area. Good. All right. Same idea on number 17. I will do the first one. Start at +3. 1, 2, 3. And I have a slope of 1. Solid line on that one, so make sure you get those details correct. Okay. Dotted line on this next one. It's going to start at -2. It's going to go down 1 over 2, down 1 over 2, or dotted line. And which of these 4 regions is it going to be? Is it going to be over here, over here, over here, or over here? Well, look at what we have here. It's got to be below the first one, okay? So it's got to be below the first one, but it's also got to be above the second one. So how much of this graph is both below the first one and above the second one? That would be the part where the two shaded areas overlap. Here's my super beautiful answer. Look at this work of art. Ta-da! Yay. All right, one more problem on here, and you didn't see this one in the answer key because there's not one single answer to this problem. You just need to create any two equations that have infinitely many solutions. Basically, that means same line, same equation, okay? You can disguise it if you want to. You can double the second one or triple the second one or rearrange some of the parts, right? Just as long as they both have the same slope and same intercept. A lot of ways you can think of that. So you can tell if you got that one right. All right. Thank you for watching. Thank you for listening. See you later.